Alright, so today we're going to continue what we were doing yesterday with the Chatelier's principle, except this time we're going to actually study some temperature effects. As you can see, there are two different graphs. One is on the left, and one is on the right. They're slightly different in the sense that they're mirror images of each other. But the most important piece of this is that one of them starts out higher and ends up lower. The other one starts out lower and ends up higher. Right here. So if you compare the beginning and end point, it'll give you an idea of whether it's decreasing or increasing. And we have different names for this. Things that are decreasing we call exothermic. And they have a delta H that is generally negative, a loss of energy. And we consider heat as a product. I think last time we talked about how if something is worth more and it goes down and you make this trade, there should be some leftover cash or leftover energy. On the other side, things that are endothermic is exactly the opposite, and we can think of it like a reactant. When you go from something that's lower, you trade for something that's higher in value, then you need to add some energy or add some cash to your transaction. So far, so good? Okay. What we're going to do now is I'm going to give you an equation, and we're actually going to write in whether it's a product or a reactant based off the things that we can discover. So let's take a look at this equation here. You see that A plus B is going to C, and we have a delta H that is negative 50 kilojoules. Based off the sign, we can say that it is exo or endothermic. It is exothermic because it's negative, which means that it's losing heat as we go in the forward direction. Should the energy be a reactant or a product? Product. Exothermic reactions, when we make that trade, should have some extra energy or cash left over. And so what I'm going to do is I'm going to then place it on the product side. So when I say it's a product, the energy or the heat goes on the right side of the equation. Okay, so if we're at equilibrium and we're applying a stress and I say something like, hey, I'm cooling it, this is like removing or taking out heat. What is the opposite of this? The opposite of taking out heat then is to add heat. And which direction will increase the amount of heat? Going to the right or going to the left? Going to the right. We expect a shift to the right because when I shift towards the right, it should increase the amount of C and increase the amount of heat or cash that I have. Questions for me? Okay, let's apply this to a real problem then. Okay, we'll just move on past this. And so a real problem would look something like this. Okay, so it has actual formulas, substances, and we're going to play around and talk about this temperature thing first. So I'm going to tell you that this reaction, as written, is endothermic. I would like you to place the word heat or energy, either one, on the correct side. So talk with your partner about where it should be located. Okay, so it goes on the left. I'd like you to physically write it in on the left. So it'll look like this. Plus, you can write heat, you can even write energy, something to represent this energy. So you can write heat or energy. Some people even just write a capital E that represents energy. But it's on the left because it's endothermic. So here's the question. If I cool the reaction, which direction will it shift? Okay, so the reaction will shift to the left. What's the opposite of cooling? So in order to add heat, we will shift to the left, which then gives us heat back, or cash back, if you will. Let's try this again. What happens if I heat the reaction? Which direction will it shift, and why? Which direction, guys? Which direction?
Right.
It'll shift to the right, but why? Why will it shift to the right?
Upgrading.
We want to cool the reaction, which is opposite, and the way we cool the reaction is we shift to the right, which is the upgrade, and that should use up extra heat energy or extra cash. Questions for me? So what does it look like when I heat the reaction? That's like turning on the heater, or handing every one of you a $100 bill. That's like getting extra cash for everybody. Does that make sense? What will more likely happen then? More people will be upgrading. Cool? You know, right now it's kind of like tax season. People are supposed to have filed their taxes. A lot of people actually get money back. It's called a tax refund. And so if you like watch TV, there's things like, hey, you can buy this thing with your tax refund. Why are they advertising these things? Because there's positive cash flow. They're trying to get you to spend it, right? Which is the opposite of that stress. If your bank account is exactly equal, like the amount of money you make is the amount of money you spend, all of a sudden you have extra cash that goes into your account. That is a stress that messed up your equilibrium. Now you have extra cash. They're going to try to get you to spend that. Cool? All right, let's try this again. Here's a new one. Ooh, I'll make this one up. All right, let's make a custom one. All right, so let's call this example 2. So okay. Oh, let me drop one more. Sweet. Now we have a gas, solid, aqueous, and a liquid. One of each. So I'm going to give you a series of stresses, and I want you to talk with your partner about which direction it's going to shift and why. I'm also going to drop this little thing called the delta H. I'm going to say it's positive 5 kilojoules. Okay, ready? Here are the stresses. Okay, stress A. Add A. Stress B. Add C. Stress C. Add D. Stress D. Remove B. Stress E. Heat the reaction. And stress F. Cool the reaction. Okay, talk with your partner about what the shift should be and why. Okay, let's assume that at some point on a test, these will be worth 3 to 5 points a piece. All right? It's really easy if it makes sense. It's really hard if you don't get this, then you're just guessing 50-50, except I designed it in such a way that you score slightly less than 50-50 because of psychology. Are you ready? Here we go. Add A. Which direction of shift?
Right.
To the right. Add C. Left. Add D.
No change.
No change. Why?
Because it's a solid.
No, D is not a solid. D is a liquid. Liquids and solids undergo no change. How about removing B?
No change.
No change. Heating the reaction.
To the right.
To the right. And cooling the reaction?
To the left.
To the left. Check.